All right, guys, so what we're doing now is we're going to do a little bit of a factoring review upon request. And this is important because the next thing we're doing is lesson 14. The next thing we're doing is solving. Solving means that you're getting an answer out of it. These verbs are really important to when you read directions. I know a lot of people just straight up don't read directions and they try to look at something and figure out what to do based on what it looks like. That's going to leave you in a lot of trouble in these upcoming sections in trig, because we are solving trig equations. But if you don't pay attention to what the directions are, something that wants you to solve a trig equation will look a lot like verifying a trig identity, which also looks pretty similar to something where you have to simplify a trigonometric expression. So simplify, verify, solve. These are all very different verbs. You have to read the directions, you have to use context clues and figure out what to do. Now, when we're solving trig equations, it will relate quite heavily to Algebra 2 when you guys were solving polynomial equations. And the way you would solve a polynomial equation is by factoring. So you had to get it equal to 0. You had to make sure that the entire polynomial was in standard form, all like terms combined, descending exponential order. And then when possible, you would factor the polynomial. Many methods to factoring. You might always want to try greatest common factor first. Then you would try maybe grouping, sum and difference of cubes, difference of squares, AC method. If none of those factoring methods work on a polynomial, it's possible that you might use something called the rational root theorem, if you remember it, and synthetic division to help you factor it further. Some things just straight up aren't factorable and they must be solved with the calculator. But right now we're going to focus on things that are factorable. Don't forget the word if something is not factorable. Do any of you guys remember the word for anything for something that's not factorable? It starts with the letter P. Do you remember it? Anyone? 5 letters. PR. I. M. What is it? Go ahead. Anyone, Haley or Dara, you could say.
Prime?
Yeah, prime. So I know we probably don't think prime goes with polynomials or quadratics, but you could have a prime quadratic. It would just be something that's not factorable. And basically we use calculators, which use calculus to approximate the answer. But don't worry about that right now. Okay. Here I have a quadratic in standard form, and I'm just going to go over how to factor this using the AC method. What I have is I have a first term, F. I have my last L. By F and L, I'm talking about first times first and last times last when you had it factored. So this is called factored form. When you were in maybe algebra 1, you were given things in factored form. Your teacher probably asked you to expand the factored form, and you would go ahead and expand that, meaning open it up. So it already is factored. And when we got it into expanded form, all right, I'm just going to use square, heart, triangle, and cloud. When you did that, they taught you FOIL, F-O-I-L, as a method to expanding this. So you would do square times triangle, first times first. Outer would be square times little cloud guy, outer. Inner is heart times triangle. And last times last is heart times little cloud guy. All right. Obviously, I'm just writing plus signs, but you know, if things are positive or negative, whatever, you carry on from there. So first, outer, inner, last, and usually, of course, there's always exceptions. Usually your outer and your inner terms combined. They were usually what we call like terms. And they would usually combine and create this middle term. When we have first, middle, last, not F-O-I-L, first, middle, last, you might think FML. I don't like factoring these. They're harder, especially when A equals not 1. When A is not equal to 1, they're even harder to factor. So maybe it makes you sad, but that's okay. We're going to fix it. So if you think to yourself, FML, I don't know how to factor this, you're going to say to yourself, I need to use the AC method. So the AC method is, we're going to multiply A times C. So that's 3 times -5, which gives us -15. Underline that on the side, okay? And then after I underline that on the side, sorry, just make sure it's all on the screen good. After I multiply that on the side, I'm going to make a list with all the pairs of factors. And you always want to be careful because sometimes more than one pair of factors multiplies to give us what we're looking at. And they also can add or subtract to give us the other number. But you got to make sure that given the right positive and negative signs, it works for both or it's no good. So I always start at 1. Don't try to be a hero. Just go in order. 1 times 15. 2 doesn't go. 3 goes 3 times. 5. 4 doesn't go. I hit 5 again, already on my list. So I'm done. The other trick for the list is the turnaround point is the square root of that number. That would be where you would turn around and work your way back up the list so you know you're done once you hit the square root. But if you need that explained more in depth, we'll talk about it another time. When you get to the B for bottom of your list, you even would say to yourself, but, B for but what? I don't only need a pair of factors that multiplies to give me what AC told me, -15, but I also need this pair of factors to add to give me -2, whatever the B value is. A, C squared. I know I have C in my equation. It doesn't really matter for that. B, C, and then this is C as in the constant. Okay. So I need the B to give me -2. So I have 1 and 15 and 3 and 5. If nothing on your list truly works, then it's likely a prime quadratic and you can't factor it with the traditional method. So if it were prime and if this were not an expression, if it was an equation and you were solving, does anybody remember what you had to do to solve a quadratic equation when you couldn't factor it to solve it? Do any of you guys remember how you had to solve those? You had to use something with the word quadratic in it to solve a quadratic equation when it wasn't factorable. Mason, you remember?
The quadratic formula.
Good. The quadratic formula. Good. So the second example on the sheet that this question's from has an equals 0 in it. That's a solving problem. If it weren't factorable, you could use quadratic formula. We're not doing that today. I just wanted to mention it. Question, Justin, or no?
No, I was just trying to find, I was trying to answer the question.
Oh, okay. No, it's all good. So we're here. So Justin, what two numbers will I use to multiply to give me -15 and that add to give me -2? Do I use 1 and 15, 3 and 5? Which ones are positive and negative? Do you know, Justin? Do you want to try that one?
No, I do not.
Okay, Ilsa?
-5 and 3.
-5 and +3. Good. If I multiply a negative and a positive, I get a negative. Good. And if I add these two, all right, I'm going to get -2. Some people definitely still struggle with like positive and negative rules. And even if you would get the right answer, I feel like you're really insecure and you would rather grab your calculator or not answer out loud because you don't want anyone to hear if you get it wrong. So I'm just going to write down on the side quickly a couple things about positive and negatives, because also what's happening is you guys are overlapping the rules for multiplication with the rules for adding, and it's messing you up, okay? So I'm just going to write rules on the side. No one needs to know. If you need to write them down and put them in your notebook somewhere, then just do it, okay? So over here, I'll do the multiplication rules for positive and negative, and I'm just going to kind of do a little visual way to do it. So if we have a positive times a positive, if we have a positive times a negative, and if I have a negative times a negative, what kind of answer do I get? Well, and this is actually the same as something as a negative times a positive. What does that equal? So what's a positive times a positive? Anyone could just shout out.
Positive.
Okay, and then what is a positive times a negative or negative times a positive? Anybody, anybody?
Negative.
Negative, negative, good. And then what about negative times negative?
Positive.
Good. Now, addition rules. Obviously, the multiplication rules are the same as division, okay? Because multiplication and division are really the same operation, all right? Over here, addition rules, which are also going to be the same as, no, I don't want to confuse you with that because, yeah, it's sort of the same as subtraction, I suppose, but subtracting is adding a negative. Gets a little weird. Okay. I'm going to do these rules a little differently. Positive plus a positive. I'll do an example underneath it, so I'm going to leave room. What if I have a positive plus, and now I'm going to draw the circle bigger. They do this sometimes with graphs when they make like a map of the United States and they make the size of the state proportional to how populated it is. So if that were the case, New Jersey would be very big, even though it's very small. So they do like the visual to help you understand. So I'm going to say a very big negative, meaning if this were 3, maybe this is negative 10. Okay, this is going to be my visual aid. What if I have a negative that's smaller plus a positive that's bigger, larger absolute value? And what if I have a negative plus a negative? Okay, and like I said, I'm leaving room under each of them so I could also do an example. But keep in mind what I mean over here. Plus negative, some of you might be thinking in your head means minus. Okay, plus negative means minus. These two here can be turned around. They could also be written as that bigger negative plus that smaller positive. Or this could be written as that bigger positive plus that smaller negative. What do you get if you add a positive and a positive? Anybody? Come on, easy peasy.
Positive.
Yes, Jonah, your hand's up from before, or you want to do something now? Here I want to know a smaller positive and a bigger negative. What do those add up to?
Negative.
Adara, agree?
Yep.
Okay, good. Negative. But what if I have a small negative and a big positive?
Positive.
Positive.
Okay. And what if I do a negative plus another negative?
Positive.
A negative.
No, that's a negative.
Negative.
Yeah, good. All right, so an example, 2 plus 3. Classic, basic example, and it equals 5. So a positive and a positive make a negative. So that example goes with that right over here. All right, this one. And if you don't know these rules, that's really what screws people up with factoring. That's like a big layer to the factoring process that messes you up with factoring, and it's going to impact you for so many things in math moving forward, in pre-calc and trig, in calculus, everywhere. And we need to make sure we fix that, okay? It's like if you don't patch the hole in the bottom of the boat, you could keep making the boat as nice as you want. It's going to sink eventually, you know? Here, what if I had something like 4 plus negative 11, which is the same as negative 11 plus 4, which is also the same as, I'm just going to rewrite this first one a little differently, 4 minus 11. What do I get with that example right over there? These are all the same.
7. Negative 7.
Negative 7, right. So this is where, these are where we need to be careful because this is where people make mistakes. So I have 4 and I have negative 11. I'm mixing ingredients. I'm mixing sugar and I'm mixing salt. And I have more salt. So my answer is going to be salty. I'm mixing my ingredients. Sugar is the plus, salt is the minus. I'm adding them up in a cup, mixing them up in a cup. the mixture is going to be saltier than it is sweet. Okay. What if I have -6 plus 14, which is the same as 14 plus -6, which is the same as 14 minus 6. And I feel like when you guys see it this way, you don't really remember all the time that it's the same as this. What do you get for this answer over here?
8.
Good, +8. Lastly, an example to go with the last one might be something like -9 plus -13, or -13 plus -9, or it could be written as even -9 minus 13, or it could be written as -13 minus 9. All of these are the same. What do I get for any of these? Go ahead and shout out.
-22.
-22. Yep, looks good to me. Okay. Salt and salt, we're going to get salty. All right. Here, a little bit of salt, a whole lot of sugar. It's going to be more sweet than it is salty. Okay. So these are just 4 different scenarios for the adding and subtracting. Here are the scenarios for the multiplication, technically, and division. Try to represent it with an example as well. So if this is something that, you want to sneak and kind of write it in the cover of your notebook so you could easily flip and look at it, do it, okay? You got to know these things. No shame. No shame when it comes to that. If, you've been using a calculator and getting by with that, you have to have that number sense, all right? So I'm just going to flip back over here. Sorry for the random tangent. So we're going to use these 2 numbers, +3 and -5. Now, to use these, we take the M for my middle term. I always draw the arrows for our visual representation of what's happening, and it's going to create the FOIL, right? F stays the same. FOI comes from the middle, all right? And then last also stays. So that's all going to happen. Sorry, I'm all the way written here. I'm just going to move it over. So 3c squared stays, -5 stays. I'm going to use these. I always write it in the same order that this is in. So plus 3c and -5c. So these are the coefficients, and you use whatever variable is over here, and we can take it from there. Now, again, I always factor, showing the same strategy. Factoring is undistributing or unmultiplying. So since distributing is associated with multiplication, factoring is more closely associated with division. So underline, greatest common factor. What's the greatest common factor above this line? And then tell me someone else what the greatest common factor is above this line. I'll write it underneath the line. The line will act in my head as a fraction bar and help me divide in my head with the pretzel method that I mentioned. And that'll help me figure out what goes inside of my parenthesis. So a couple hands are up. I don't know if they're just up from before. So just to point out, Adara, Moreau, Jonah, your hands are up. So if you want to keep them up, fine. But I just want to know, can someone tell me the greatest common, and again, I'm warning you of the next questions. I want the greatest common factor here. I want the greatest common factor here. I'll bring those out front, and then I want someone to reduce this pretzel style, tell me what's left inside, reduce this, and tell me what's left inside. So like the next 4 questions you basically know. So what goes here for the greatest common factor? Can you tell me that, Sydney?
3c.
Good. What do I write underneath this line for the greatest common factor? Go ahead. I just spoke to all you people. Go ahead, Mason.
-5.
Good. And I appreciate that he mentioned the negative, okay? This sign, big star in your notes or whatever you need to do, bells and whistles going off, whatever sign the first term is that you are using above the line, that sign, S-I-G-N, not like cosine, sine, tangent, that sign is associated with the GCF underneath. So that is a +3c squared, so I use +3c. I write those down for myself, help myself with the visual. Then if I'm going to divide this by 3c, I also need to multiply by it to keep it balanced. That's why it comes out front. Then the -5, if I'm dividing by -5, I also multiply by it again. That's why it comes out front. When you reduce, this step is also so important. I might go to the next page and write something down for you as well. When you have adding or subtracting in the numerator and you want to reduce, I draw my little pretzel guy. And when you reduce, that has to reduce with both parts, or if there's 3, with all 3 parts. Once I have 3 or more parts on top, you always will have 1 part on bottom if you could reduce. To me, I call it more of a peacock, not a pretzel anymore, because it starts to look like feathers, like a hand turkey. But it has to reduce from everybody. You can't just be like, cross it out, bye, gone. That's not what that is. So just to compare for a moment, I'm going to flip right back on this little cloud over here. If I have 2x plus 6 over 2. If I wanted to reduce that, I would reduce it by, or actually, let's even make this, I'll make that a 12. I'll make that a 22. I'll make it a little bit more interesting. And yeah, I have to reduce this and I have to reduce this. If you have a plus or a minus sign in between. 22 over 12, I can reduce both by 2. I get 11 over 6x. There's my plus sign. And then 6 over 12, careful because people write down 2 a lot, but that would be 1 over 2. Okay? Even if it matched that last number at the side and you want to cross it out, it becomes a 1, not a 0. However, if you have a squared, let's do 6a squared b to the third c times 8a b c to the fourth, whatever, over 2 a b c. I don't have a plus or minus sign. I don't have a plus or a minus sign at all in this example. If I want to reduce or simplify this one, what do you think you will be left with in your numerator? And just be careful. I expect people to make a mistake here. Maybe you will, maybe you won't. But what will I get in my numerator? Jonah Moreau, hands are still up. So remember we said put them down if you don't want them to be up. So I hear them raise. But if you re-raise it, that's all good. Can somebody tell me what they think goes in this numerator? Max, you want to try?
3
Sure.
times 4.
Nope.
Well, like after the ABC.
I know. That's exactly the example I wanted the person to make. So thank you, because you're doing it exactly right. You reduce from everybody like that when you have a plus or a minus sign. However, if you don't, if everything's being multiplied, this comes up a lot in trig. If I reduce the 2 from the bottom, from the top, you only reduce it 1 time. It doesn't reduce like a pretzel where it comes from everybody, because I could have just multiplied 6 and 8, got 48 over 2 and got 24. You wouldn't reduce by 2 twice, because then you're dividing by 2 twice. That means you're really dividing by 4 and you're changing the problem. So that example that Max just pointed out for us is perfectly staged, because that is what everyone does by accident. So if you reduce it from the 6, you do not reduce it from the 8, or vice versa. You just choose. Same with now the A, the B, and the C. You can't reduce them twice. If it were a plus sign or a minus sign, yes, you reduce it from everybody. That's when the pretzel comes in, okay? So the A, B, and C, I would reduce, say, A with the A, B with the B, maybe make my life easy, C with the C. Everybody else is still in the problem, okay? So maybe jot that down for yourself. So next time you get into a situation like this, you could be like, which way do I reduce? And then you have somewhere to reference, So that'll be 3a squared, b cubed, c to the fourth times 8. So 3 times 8, I can even make into a 24 instead, Over nothing, you're done. 24a squared, b cubed, c to the fourth. Okay? But perfect, Max, because you pointed out exactly what I wanted, all right? Do you see the difference in them? Or is it still a little confusing? Max, you good? Or anyone else? Do you see the difference in the two situations? Or are you confused? Hello? You're responding on mute. I don't hear you, so. Going once, going twice? No? Hello? Talking to myself here. All right, great. So going back, I'm going to reduce. Who can tell me if I reduce now, it's a pretzel with the plus sign in the middle, all good. If I reduce, what goes inside of these parentheses? Hands up if you know. Give me the answer for this parenthesis. Go ahead, Adora.
C+1.
You're the best. C+1. Careful, like I said, that's not a 0. And what about the answer for what is the expression inside of this parenthesis? You definitely want to be careful here because, you know, the Mason pointed out the negative on bottom. You want to make sure you take your time to get the right thing. So we're going through this over here. Who can tell me? Go ahead. You want to try, Justin?
3C minus 5.
For this reducing, what is negative 5c over negative 5 reduced to? Like if it was just that oval right there.
This C, right? C.
Yeah, that's just going to be C. And then what about just that oval?
1, I think?
Yeah,
Or
plus 1. You're
1.
right. I know a lot of times you guys get weird when it's like a 1 or a 0 in a problem because it feels too naked or something. You're like, that can't be right. But yeah, it's C plus 1. So in here, I'm just going to go over it with the orange highlighter so we know it came from the pretzel, okay? So C plus, maybe I should make it a little bolder. C plus 1 and C plus 1 right over here came from those. And then the 3C and the negative 5 came from what my GCF was, which was underneath over here. So there's 3C and negative 5. And then those get brought out front. Now, this next step is also where a big red flag happens because a lot of people will get the factored form on their paper, but it's like you guys are going through motions and I don't think you always understand why you're writing what you're writing. I need you, I know it's not a word, I need you to look in this step and see if you have a greatest common factor. Do you have something a little bigger and chunkier that is common to the both parts of the equation? What are both parts? Both parts are here. We have this whole part under, or above rather, the blue squiggle. That's the first part. And then the second part or group, because this is grouping, is that blue squiggle over there. What is not our GCF, like here just was 3C, negative 5. I want, think bigger. What is our greatest common factor in this problem? What is some big chunky thing that is common to both blue squiggles? What is?
C plus 1.
That was, where'd that come from? That was Justin or no? Justin, was that you? Yeah. Ilsa, we're going to say the same thing?
Yeah, it was.
Good. So C plus 1 is our greatest common factor, and that should really get pulled out front. More often than not, I see kids write 3C minus 5 first, and then C plus 1 after it. And that just sort of tells me like, yeah, you can get it factored, but you're writing it down because you just know that that's the answer. I don't always think you understand what happened to get from one step to the other. So that is common. If this does not match, if it does not match, it's not either you made a mistake or it's not factorable. Because you can't factor something out if it's not common, you know? C plus 1. And if I factor out that C plus 1, it's out front now. Just like you factor out a 3, you factor out an X. So I factored out C plus 1. What's left inside if I took out a C plus 1? What's left inside? You can type it in the chat if you don't want to speak out loud. You could raise your hand. We could do it over here. Go ahead, Morel. What would it be?
3C minus 5.
Perfect. And we're done. And now there's no reason ever to get a factoring example wrong and not point it out. So if you ever take a test or a quiz for me and you factor something and you get it wrong and you don't tell me that you know it's wrong, you lose maybe say, depends on your mistake, but let's say you lose 4 points. Okay. But if you factor something and you check it and foil it in your head and you know it's wrong, but you can't find your mistake, but you leave it on your paper and you write a little note, checked this, I know it's wrong, can't find my mistake. Well, maybe you only lose 2 points now instead of 4 because you acknowledge the fact that you know it's wrong. That's a big deal, okay? So always remember that. So that is how we factor that first example right there. We have a quadratic, quad meaning 4, quadratic trinomial, and I called it FML. First, last, but we have a middle. The middle came from outer, inner being combined. Quadratic implies 4. 4, F-O-I-L, FOIL has 4 letters. That is our FOIL quad. So when you have FML, we want to break up the M into OI. So we have a quad, 4 pieces. And once you have 4 pieces, we can factor by this method, which I just stated a few minutes ago, which is called grouping. We factor by grouping. I went over the pretzel. I went over reducing. I went over a bunch of rules, the greatest common factor, la-di-da. There we go, okay? We talked about if this were an equation, it would have an equal sign. You would solve by getting it equal to 0, factoring, and then we would use something called the zero product property. I'm going to record that one next. It should be a little faster because I went into a lot of detail here. And you would set each factor to 0 and solve by setting them to 0 and solving for the variable. And again, that's called the zero product property. If something's not factorable, it is prime. And if you have to solve a prime quadratic, we have something called the quadratic formula, which we use to help us do that. Okay. So if you're watching the video of this and you understand it, and you feel good about it for your inventory purpose, you could put thumbs up on it. But if you're confused still, or you need more clarification, or you aren't that confident at it, put a thumbs down on it. And I'll use that to inventory and kind of see what you guys need more help with moving forward. Okay. So I don't care if it has a lot of thumbs down on it. It's fine. I won't be offended. I'll just help you guys understand things better. All right. Hope this was helpful for you guys.